Welcome viewers, in this video we will see the solved problem based on the tie-set schedule. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic tie-set schedule, solved problem 3, coming under network topology. For the network shown, draw the graph, tree, tie-set schedule and current through 20 ohm resistor. Also find the voltage across the elements. Voltage across all the elements. So this is the given network. So the network is nothing but combination of interconnection of the elements. Here two voltage source available, three resistors are available. It's interconnected. It's called a network. So this A, B, C is nothing but a node. Node is the junction point where the elements are connected. Node A, B, C and D. So from this network we can draw the oriented graph. That is nothing but the elements are replaced by the straight line. Only simply the line will be drawn. That is called a graph. If the directions also available means it is called a oriented graph. Elements replaced by line is a graph. Directions are available mean oriented graph. So here we have four nodes A, B, C and D. The branches 1, 2, 3, 4, 5. Branch is nothing but a element connected between the node. This one is nothing but a 20 voltage source. 2 is nothing but 10 ohm. 3 is another 10 ohm. 5 is 20 ohm. 4 is 40 ohm, 40 voltage source. So these directions are given according to our own directions are given. Directions are not specified in the problem. So the first question is we need to draw the graph. So this is the graph of the given network. Now we'll see the further detail. So the number of node available in this problem n suffix t is 4 nodes A, B, C, D. Total number of branches B equal to 5. There are 5 branches are available. Then total number of tree branches. Tree means subset of the graph. Part of the graph is called a tree. That is not a closed loop. We can draw the n number of trees from the oriented graph. So how many branches are available in the tree is the number of tree branches. That can be calculated n equal to n suffix t minus 1. Number of nodes minus 1. 4 minus 1, 3. So there will be 3 branches in the tree. Total number of link L equal to B minus n. 5 branch minus 3 branches. So 5 minus 3, 2. 2 links will be there. The number of independent link equal to 2. Already we have 2 loops are available. This is the loop. Loop 1, loop 2. Loop means closed circuit. Current in the loop 1 is I1. Current in the loop 2 is I2. Now we'll see the tree. This is one of the tree available for the given network. 1, 4, 5. 3 branches are available. Node A, B, C and D. So it is not a closed loop. Part of the graph is the tree. All nodes are available. Branches are 1, 4, 5 available. So the remaining 2 and 3 will form the link. Let branches 2 and 3 form the link. Link is nothing but closed circuit. So by using 2 and 3, by connecting 2 and 3, we can go for the link. So the tree with the link is called a tie set. Tie set means link with the tree. So here the tree is contain the branch 1, 4, 5. Link is 2 and 3. Now we'll see the tree with the link, that is called a tie set. The diagram for tie set. So this is the tie set. 1, 4, 5 tree. Then 2 and 3 is connected. That is a link. So that will form the closed circuit. Loop 1. Current flowing through the loop 1 is I1 in clockwise direction. This is loop 2. Current flowing through loop 2 is I2. That also clockwise direction. Loop 1 contains the branch 1, 2, 5. Loop 2 contains the branch 3, 4, 5. From this we can go for the tie set schedule. So this vertically we have the loop number. Loop 1, loop 2, 1 and 2. Horizontally we have branch numbers. There are 5 branches are there. 1, 2, 3, 4, 5. The loop currents are described by the small letter I1, I2. The branch currents are described by capital letter I1, I2, I3, I4, I5. Now we can see the relation. The plus 1 indicates both the directions are same. Minus 1 indicates both the directions are opposite. That is the loop current and branch current direction. 0 means there is no current. Now see, this current I1 is flowing in clockwise direction. See, the current direction of branch 2 and loop 1 both are same. So this is also flowing this side. So branch 2 is plus 1. Branch 5, that also same. Going down, both are going down. So plus 1. In loop 1, so it is flowing like this, clockwise direction. So that also same, plus 1. 3 and 4, the loop current I1 is not flowing through 3 and 4. So 0. 3 and 4, 0. 2, 1, 2, 5, all are same direction. So it is indicated plus 1. Now we'll see the loop 2. See the direction. Branch 3 and I2 both are same, plus 1. Here also same. So plus 1. See this side, here this I2 is going upward, but branch current 5 is going downward. So minus 1. 1 and 2 no connection. Branch 1 and 2 not covered with the loop 2. So 0. So this is called a tie-set schedule. Tie-set diagram and tie-set schedule. Loop current and branch currents are related. Both the directions are same in plus 1. Opposite means minus 1. Not flowing means 0. From this we can easily write the voltage equation and current equation. We can see later, but I will explain how to write the voltage equation. So this, consider the first row. So 1 into V1 plus 1 into V2 plus 0 into V3 plus 0 into V4 plus 1 into V5. Like that we can write the equation. Similarly, in the second row, 0 into V1 plus 0 into V2 plus 1 into V3 plus 1 into V4 plus minus 1 into V5. We can write the voltage equation. Similarly, I will write the current, branch current I1. See this I1. I1 in terms of loop current. So this is only plus 1 is available. One loop 1 plus 1. Loop 2 0. So I1 equal to capital I1 equal to small I1. Because here two currents are there. One current is 0. So only 1. So capital I1 equal to small I1. Similarly I2. Only here plus 1 is there. I1 is plus 1. I2 is 0. So capital I2 also small I1. For I3. I1 is 0, I2 is 1. So capital I3 equal to small I2. Similarly I4 also. I1 is 0, I2 is plus 1. So capital I4 equal to I2. Right? So I1 equal to, capital I1 equal to small I1, I2 equal to small I1, I3 is small I2, I4 also small I2. For I5 both the values are available, plus 1, minus 1. So we need to subtract I1 minus I2, positive minus negative. I1 minus I2, capital I5 equal to I1 minus I2. So we can write the voltage equation as well as the current equation, branch current in terms of loop current from the tabular column. Now we'll see the further. I1 and I2 are the link current. The branch currents are capital I1 to I5. V1 to V5 the voltages of the branches 1, 2, 3, 4, 5 respectively. Right. Now we see the voltage equation. What we discussed, voltage and current, we'll see the relation. So what we discussed here, for the first row we can write 1 into V1 plus 1 into V2 plus 0 into V3 plus 0 into V4 plus 1 into V5. So these values are from the tabular column, tie-set schedule. So these two values are 0, only we have V1 plus V2 plus V5 equal to 0. We'll take the equation number 1. Similarly, second row, 0 into V1 plus 0 into V2 plus 1 into V3 plus 1 into V4 plus minus 1 into V5. So first two values are 0 over V3 plus V4 minus V5 equal to 0. We'll take this equation number 2. So from the tabular column tie-set schedule, we got the voltage equation, 2 equations. For the two rows, we got the 2 equations. Now we'll go to the current equation. What is the current equation from the tie set schedule. So this is the current equation what we discussed already. Capital I1 equal to small I1, I2 equal to small I1, I3 equal to small I2, I4 equal to small I2. This is not I4, I2. I5 equal to I1 minus I2. So the equation 3, 4, 5, 6 are. Now branch voltages. There are 5 branches are there. V1 equal to minus 20, V2 equal to 10 I2, V3 equal to 10 I3, V4 equal to minus 40, V5 equal to 10 I5. What is this value? This 20 is the voltage source already available. This minus 40 also voltage source. This is V equal to I into R. R value is 10 ohm. I value is I2. Now I will refer the diagram so that it is easy to understand. So this is the branch 1. Branch 1 is minus 20 voltage. Branch 4 is minus 40 voltage. Branch 2 V2 is nothing but 10 ohm. So 10 into I1. This 3 is nothing but this 10 ohm. 10 into I2. This 5 is nothing but 20 ohm. But here both the currents are flowing, I1 and I2. So I1 minus I2. 20 into I1 minus I2. So that is written in that equation. Now in this voltage equation we can substitute the value of I2, I3 and I4 from these equations. So that we can able to find the branch voltage and current. So that the V1 already available minus 20, V4 is minus 40. Only we need to find V2, V3 and V5. V2 equal to 10 into I2, but I2 is nothing but small I1, so 10 I1. V3 is 10 I3, I3 is nothing but I2, 10 I2. V5 equal to 20 I5, I5 is nothing but I1 minus I2, 20 I1 minus I2, right. So now we got this V2, V3, V5, V1 and V4 already available. So we can substitute this equation in the first and second equation, that is the voltage equation. From row 1 and 2 we got 2 equation. In that we can substitute these values. Now consider the equation 1, V1 plus V2 plus V5 equal to 0. Now we'll substitute the value of V1, V2 and V5. V1 is minus 20, V2 is 10I, V5 is 20 of I1 minus I2. Now we'll multiply this so that 20 I1 minus 20 I2. So minus 20, 10I plus 20I become 30I. Minus 20 I2 equal to 0. Bring this minus 20 that side, so it become plus 20. So divide by 10 so that 30 become 3I, 20 become 2, 20 become 2. So 3I1 minus 2I2 equal to 2. I will take this equation number 13. Now we'll go to the second equation. V3 plus V4 minus V5 equal to 0. Now substitute the value. V3 is 10I2 plus V4 is minus 40. V5 is 20 of I1 minus I2. We'll multiply inside. So minus 20I plus 20I2. That this minus and minus become plus. So 10I2 here, 20I2 is there, so it becomes 30I2. Then minus 20I1 minus 40. Bring this minus 40 that side, it become 40. Here also divide by 10, so it become minus 2I1 plus 3I2 equal to 4. This is equation number 14. So we need to find the value of I1 and I2. Now we got two equations, 13 and 14. For finding two variable we have two equations. By solving these two equations we can easily find the value of I1 and I2. See here 3 I1 is available, here minus 2 is I1 is available. So we'll multiply the equation 30 with 2, equation 14 with 3. So that we'll get 3 into 2 6. We can easily cancel the term I1. Now we'll go for the simplification. So equation 13 is multiplied with 2, equation 14 is multiplied with 3 in order to bring this I1 as 6. So here plus 6I1 minus 6I1. So simply we can add the value, so that while adding it automatically got cancelled. So 9I2 minus 4I2. So 5I2. 12 plus 4, 16. So I2 equal to 16 by 5, that is nothing but 3.2. So I2 equal to 3.2 amperes. Now we got the value of I2. Now we can substitute this I2 value in equation 13 so that we are able to find the value of I1. So we'll consider equation 13, 3I1 minus 2I2 equal to 2. Substitute the value of I2 equal to 3.2 ampere. So 3I1 minus 2 into 3.2 is 6.4 equal to 2. Bring this 6.4 that side, so it becomes 6.4. 2 plus 6.4, 8.4. So I1 equal to 8.4 divided by 3, that is 2.8. I1 value is 2.8 amperes. So now we got the value of I1 and I2. So the loop currents are calculated. Now we go to the branch voltages. By using this, we can easily calculate the branch voltages. So V1 equal to minus 20 voltage already available. This is a voltage source. V2 equal to 10 I1. I1 value is 2.8. So 28 voltage. V3 equal to 10 I2. I2 value is 3.2. So 32 voltage. 10 into 3.2, 32 voltage. V4 is minus 40 voltage. This is a voltage source already available. V5 equal to 20 I1 minus I2. That is 20 of 2.8 minus 3.2. So 20 into minus 0.4. 2.8 minus 3.2 is minus 0.4. So that is 20 into minus 0.4 is minus 8 voltage. So now we calculated the branch voltage also. So in this problem we discuss the tie set schedule. Given network, first we draw the oriented graph, then tree with the link is called a tie set. From that we receive the tie set schedule. Using the tie set schedule, we framed the voltage equation and current equation. By solving these equations, we are able to identify the value of loop current I1 and I2. From that we calculated the branch voltage V1 to V5. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.